Welcome to Khetztutorials, and in this video, which is the last installment of the series that I've been doing about circles, I will be talking about tangents. So once again, we are talking about tangents just like we did in calculus. So tangents, but this time with reference to circles, so tangents to circles. And I just have one statement to make about this because there's only one thing to say. And then after that, I'll just dive into an example that shows how you'd apply the theory. So let's say you have a center over there. The theory says a tangent to a circle is perpendicular to the radius at the point of contact. So a tangent, once again, is a line which touches, but in this case, it touches the circle at some point. Let's call it T, right? We can call it anything, but let's call it T for now. And we're basically saying that it touches at this point, it touches the circle at that point. Now, if we draw a radius which is a line from the center to the circumference, but now specifically at this point, then we basically are saying that this radius will be perpendicular to the tangent at that point of contact. And even if you had a diameter which is twice the radius, so even if you have that, within a diameter you still do have a radius. So don't forget or don't mess that up. You also do have this property holding, or it's also a valid property even if this was a diameter, right? So once again, or let's write it in words. A tangent is perpendicular to the radius, or a radius, it's not a specific radius, to a radius at the point of contact. So once again, just like in calculus, we're talking about a straight line. We're talking about a specific point of contact. And we're talking about the equation that defines the tangent and some other things that may follow. But these are the basic things. We're talking about the straight line, which is the tangent itself. We're talking about the specific point, which is the point of contact, and we now want to find the equation of that tangent. And you can find the equation of the tangent because if we say that the tangent is perpendicular to the radius, then that means that the gradient of the radius, which would be the gradient from the center to that point, right? So the gradient of this thing, you can find that if you have a point there, and you have the coordinates of this T as well, then you can find the gradient, right? You can find the gradient of this line just using the formula. M equals to y2 subtract y1 divided by x2 subtract x1. So from this, you can find the gradient of CT, which would be mrad for the radius of, or for the gradient of the radius. Now, according to this, or we know, even from the first video, which I'll link at the top right, we're saying that if lines are perpendicular to each other, then if you multiply their gradients, then you basically get -1. So now from this property, or from this calculation, we can find either the gradient of the radius or the gradient of the tangent, right? So you can find any of those two, and this is an important thing to us at this moment. So I think that's just about all that I had to say. And I wouldn't want to end the video here without doing any examples. I don't think I did any examples in the previous videos, or I don't think the examples were enough. So I just hope that the example that I'll do now will kind of clear things up so that you know how to apply this stuff. So let's copy, first of all, let's copy this circle because I want to use it. Now I'm just going to take it down here so that I draw my example. Okay, so you're now coming down here. And the example looks something like this. Let me draw the Cartesian plane. I'm trying to center this because this diagram or this circle is centered at the origin. I don't think I'm doing a good job at that, but let's just assume that this circle is centered at the origin. So at the origin, that's where we have the center. So center at the origin. Let's keep that in mind. And this is just the Cartesian plane. We have the x-axis and the y-axis over there. And now also we have a tangent. I just use a different color for the tangent, and it passes through that point somewhere there. And it's labeled as P, and then at the point of contact we have R, then we have Q somewhere there, right? And we have this R given to us as 6 minus 2. And I have two questions. I just basically extracted two questions. And the first one says, what is the equation? So the first question, what is the equation of the circle? And I can think of two ways that you can actually find this equation. So let's first write out the standard form of our circle. And from the standard form, we can see that we do have a point on the circumference. Remember that the x and the y describe all the points that are on the outline of the circle on the circumference. Now this point R is the point of contact of the tangent PRQ. So PRQ is a tangent, don't forget, PRQ is a tangent. Now, since it's a tangent, it touches the circle on its circumference. So R is on the circumference. Now, you can either substitute this point into the equation to find R, or you can actually find the length from the center to R to find your R, which is the radius. Then substitute the coordinates of the center. In this case, the coordinates of the center are just 0, 0, because this is the origin. Our circle is centered at the origin, so we can do something like that, because the A and the B would just be 0, and this is what we'd have. And now the task would just be to find the R. And as I said, you can either find the length of this using the distance formula. You'd say starting at, so let's call this O, and this would be R. So the length of OR, which is the radius, would be, if we start at the origin, it would be this, starting with the x's. Let's start with the x's, and then the y's. So this is what you'd get if you were to use the distance formula. And in here we have 36 plus 4, which would result in the square root of 40 units as the radius. Now you just basically take this radius, which is R, and substitute it in there. And this is a square root sign. Once we square that, it would just become 40. So here's our answer, and here's one way that you'd actually find this, just to show what happened over there. Basically did this because this is R squared, and you'd finally have this as your answer. And another way that you do this is you'd once again see that your center is at 0, so the origin, which is 0, 0, and you're at this point. And you can substitute any point on the circumference of the circle. In this case, we have this point on the circumference, which is R, which has coordinates 6 minus 2. And now if you do that, you have 6 and minus 2. Then you have R squared over there. Then you're going to have 36 plus 4 equals to R squared. And you can directly substitute it in here because R squared is that thing over there. And you know that R squared would just be equals to 40. And the standard form has R squared on the outside. So you can just substitute this thing exactly as it is and have this as your answer. So those are the two ways that I could think of to actually find the answer to this particular question, which asked for the equation of the circle. So that is how you'd find the equation of the circle. Let's write it up here just so we store it somewhere. So the equation of this circle is x squared plus y squared equals to 40. Now I just want to erase this so that we have the diagram in view as we move on to the next question. And the next question, which has 5 marks according to the book that I'm using, which means there's some work to be done over here. So The next question asks for the equation of the tangent. So question 2, what is the equation of the tangent? Now let's apply some reasoning, or let's go back to theory. What information do we have? So okay, we have the equation of the circle, but is that useful? I don't think so. What else do we have? We have a tangent and we know the point of contact. Okay, we are now getting somewhere because we are now talking about the tangent specifically. And once again, what relationship do we know, or what do we know about the tangent and the circle? We know that at the point of contact, the radius is basically perpendicular to the tangent. Okay, so what does that mean? That basically means that the gradient of OR multiplied by the gradient of the tangent, which is PRQ, is equals to -1. And can we find the gradient of any of these? And yes, we can, because if you look on OR, we basically have 2 points, the origin itself and R. So I can use those 2 points to actually find the gradient of OR. So doing so, and starting at the origin, this is what we have. This is what we'd have, change in y divided by change in x, and at the top we just have 2, at the bottom we have -6. This will be the result, and in simplified form this is as follows. And we can then substitute this thing into that equation and say we have -1/3 multiplied by the gradient of PRQ is equals to -1. So from this we can then find the gradient of the tangent, which is PQR, and you just basically multiply on both sides, or whatever method that you'd use, and your final answer, if you multiply both sides by -3, then you do, let's multiply both sides by -3. That would cancel, that would cancel, that would become positive, and you'd have this equals to, so this is -3 equals to 3, right? And this would be your gradient for the tangent. So we now have the gradient of the tangent, and the tangent is a straight line, so we use the standard form of a straight line, and the gradient, we found that to be 3. We can just simply substitute that gradient into this formula, and the rest we can basically find from just substituting any point on the line, and we only have 1 point at our disposal, so we can just use that point that we have. That is enough, it should be enough. And we have -2 equals to 3 multiplied by 6 plus c, and c is the only variable, which means we can then find that c, and this is just c equals to -2, -18, c equals -20. And we now have the equation of the tangent in its full form. But then how did we get to this answer? This is basically the answer. How did we get to this point? We used the fact that at the point of contact, the radius is perpendicular to the tangent. And usually you can find the gradient of the radius, just like we did over here. And you're going to use this equation, which is related to the 2 lines being perpendicular, to find the gradient of your tangent. Then after finding the gradient of your tangent, obviously you will have a point of contact, or you can find the point of contact in many other ways if you're not given this point of contact. Just make sure that your approach is centered, or it basically revolves around the theory. So I basically used what we know, or what I talked about specifically in this video. And once again, with maths, you just basically be going back to the theory. So as long as you know the stuff, as long as you know what the theory says, you should be good to go. So just revise all of this, just revise the facts. The questions are always going to be different, but once you know your stuff, you should be able to apply that to different questions. So that is it from me, and I think that is all that I'll talk about with regard to circles. I will now move on to the next topic. If this video was of value to you, please give it a thumbs up, and if you haven't subscribed, please subscribe. I will see you in the next video.